Hello, good day. My name is Luke Samuel P. Silleza, and I'm here to present about the result of my entire interview from a professional engineer about his real-life applications, challenges, and risks about the statics of rigid bodies in his workplace. So again, I'm going to share some of the answers from my questions by a real professional engineer. I asked this person years ago for me to be assisted in my thesis, and right now I'm going to introduce Mr. John Alcantara, how he's able to apply statics in his workplace, and how he's able to give some advice to us, especially fresh graduate engineers, and how to tackle and apply physics really in the workplace.
Good day, everyone. On behalf of Luke Silleza, I would like to introduce myself. I'm John Alcantara. I graduated at PUP Santa Mesa with a bachelor's degree in electrical engineering. I'm working in a construction company and we are engaged in commercial, industrial, and infrastructure projects. I am a department head for inventory planning, control, and warehousing, and asset management under logistics division. My main task is to manage, utilize the company's resources such as available materials, stocks, tools, small and heavy equipments, service vehicles to support all our ongoing projects. Also, I direct manpower and delegate tasks to ensure our operation to run smoothly and efficiently. Now for the first question on how important it is to be familiar with statics in my working environment. The answer is very important that you have a fundamental knowledge in statics. So to keep my working environment safe and make the daily activities more efficient. To cite some examples, in our warehouse facility, we have to move and store different construction materials varying in sizes and weights. Our daily activities are very labor intensive as we move stocks from one point to another, loading and unloading materials from delivery vehicles to our storage racks or vice versa. This involves knowing the weight capacity of the delivery vehicles and the storage racks. Another example is that we have a 3-level mezzanine storage rack structure. This mezzanine structure has a rack rated at 2 tons for every rack. And its walkway is rated at 365 kilograms per square meter. So with that data, we need to keep all our stored materials in the rack securely so it won't move, and it's well within its weight capacity. Otherwise, the structural integrity of the mezzanine will be compromised. So the benefit of static is that with that knowledge, when you have that knowledge, first and foremost is the safety factor, and secondly the efficiency. So having this knowledge, we can keep our stored materials in a safe and secure manner, to keep it from any movement. So there won't be any untoward incidents or accidents that can happen inside my warehouse facility. For its efficiency, uh, we are providing our personnel with material handling equipments, with its carrying capacity to help our workers to lift and move materials with less effort, and minimize injuries and accidents. This following material handling equipments that we have these examples: the hydraulic manual lifter, pallet jacks, forklift. We have scissor lift, truck mounted man lifts, truck mounted boom crane. The challenge of statics, uh, in its practical use, is that we must always be aware and to constantly be reminded of its effect if we disregard the physics involved in it. So my instruction to my coworkers is to maintain the load capacity of any equipment, delivery equipment, and storage racks, um, to avoid overloading. I also give them instructions to monitor and check the structural integrity of our storage racks and identify any wear and tear and any potential weaknesses on the structure. So my advice for our future engineers, that uh, you have to take in all the knowledge as much as you can when you are still in your school. Develop your social skills. You will be interacting with different kinds of people with different kinds of background, so you have to be very flexible. Hone on your reporting skills by using Microsoft Excel, Word, and PowerPoint, because this will be uh, these skills will definitely help you out in your daily activities. Don't be ashamed to start small or to be at the bottom. Work your way to the top. It will be more rewarding in the end. Take advantage of your co-workers' experiences. This will give you different insights and train techniques that you will never learn in school. And lastly, I always say this to my co-workers and newly hired workers. If you're in doubt, if you are given an instruction or a task, always ask again or confirm that you understood the instruction correctly, so to avoid miscommunication, waste of time and resources, and importantly, to avoid accidents in the field. So again, always prioritize your safety and the safety of others around you when you are working in the field. So I hope I've given you something that can help you out when you are working in any engineering discipline, and you will be working in the site or in the field. So thank you very much. Good luck to you all.
Wow. Thank you so much, Sir John Alcantara, for such wonderful answers and applications about the questions. And again, thank you so much for your time, for being with us for tonight, and of course, being involved in my presentation. So right now, we are going to my main presentation for this activity, which is I'm going to discuss the real-life applications of a based from the interview of Sir John Alcantara and real life focuses of statics of rigid bodies as well as the challenges, the risk, and the other related information relative to the application of statics of rigid bodies. So let's go. So right now, my first point actually is that uh, we need to again to review some of the basic definition on this report and my presentation. So again, when we define statics, it is used in the analysis of structures, for instance, in architectural and structural engineering, which is why we needed the help of Sir John Alcantara. And again, the strength of materials is a related field of mechanics that relies heavily on the application of static equilibrium, which focuses actually on the workplace of the company where Mr. John worked. They really manage the equipments used in the constructions, of course, and the safety of which infrastructure that they help to build. So it directly focuses and really connected to our topic and of course in the discussion is static rigid bodies. So this means there are no unbalanced forces on the body. Thus, the body is either at rest or moving at a uniform velocity. Dynamics is a study of bodies which are not in equilibrium. Thus, there is acceleration. So right now, I'm going to some real life applications, which is directly connected from the interview. I'm going to give some examples. Again, in our daily life encounter, where really physics, which is the main branch of statics of rigid bodies, connected to. Okay, so number one, the weight of a body. The weight of a body is nothing but the amount of gravitational force acting on it. The gravitational constant is the same for all the objects present on the surface of the Earth. Therefore, the weight of a body does not vary or change with change in location. Hence, the weight of a body is a prominent example of static force. Next is the alarm clock, of course. Physics gets involved in your daily life right after you wake up in the morning. The buzzing sound of an alarm clock helps you wake up in the morning as per your schedule. The sound is something that you can see, but hear or experience. Physics studies the origin, propagation, and properties of sound. It works on the concept of quantum mechanics. Next is the headset. When you get tired of work or studies, listening to music comes in handy. I totally agree. Since as a musician myself and a music lover, have you ever thought about how do your have headphones, earphones work? Well, it's again because of the physics. The concept of magnetism and sound waves are involved in the science of your headphones and earphones. When you plug your headphones and earphones into an electric source, the magnet in your headphones, earphones creates an electromagnetic field which ultimately results in sound waves. Next and last, a portrait hung on the wall. When an object is hung on a wall, it is acted upon by a number of forces. The gravitational pull of the earth tends to pull the painting in a downward direction. At the same time, the push force and the reaction force offered by the wall keeps the painting in place. These forces do not make the painting change its position or state with respect to time. Hence, it serves to be an ideal example of static force. Now we are going to the real life challenges, of course, of the physics of the entire physics and engineering that we face right now, especially that directly connects to the future generation, which directly, of course, connected to the statics of rigid bodies, which is number one, of course, is the global warming. So right now, um, the global warming is a real threat that needs no further explanation. The ever increasing temperature of the Earth has caused an unprecedented melting of glaciers and resulted in aberrant weather patterns. Through means of energy efficient engines and low carbon footprint of machines and equipment, we can curb this danger. Such solutions require the development of machines and equipment that has low carbon emission and thus help in tackling the problem of global warming. Many secondary schools have started teaching students more about the threats of global warming. Tuition classes such as physics tuition for Sec 3 also offer a glimpse into this area. The number two is the food production. Unfortunately, many parts of the world are battling famine, drought, and malnutrition. The impact of these problems can be minimized by increasing food production, actually, while most people would associate food production with biological and environmental studies. Physics can also play a significant role in this field by employing improved irrigation designs and harvesting techniques. It is possible to increase crop yield and make more food available for human consumption. And of course, we have also medical applications. Robotic surgery is a ray of hope for treating ailments in part of the body that were not previously inaccessible. Various subfields of physics, such as nanotechnology, have resulted in exceptional advancement in medical procedures. In addition to robotic surgery, the principles of physics are applied to create nanoprobes that are incredibly efficient in diagnosing ailments by delivering drugs at the target site. And lastly, we have energy crisis, which is really inevitable. It is no secret actually that we are running short of non-renewable source of energy. Thus, the quest for clean energy is rapidly growing in scale and relevance. This is where physics comes to the rescue. Nuclear physics is another field of physics that allows humans to tap into the unlimited potential of atomic energy for the benefit of mankind. It can pave the way for sustainable and clean energy sources that we may be extremely important in the near future. Now, for my last point in this presentation, I'm going to the relative application. And again, as a reminder and a review, what really statics is. The most important application of statics is to study the stability of structures, such as edifices and bridges. And in these cases, gravity applies a force to each component of the structure as well to any bodies the structure we uh, or may need to support. Statics is used to the analysis of structures, for instance, in architectural and structural engineering. Strength of materials is a related field of mechanics that relies heavily on the application of static equilibrium. So that would conclude my presentation in statics of rigid bodies, along with some reflections on the answers of our from Mr. John Alcantara. And I hope I was able to shed some more useful information and connection of this entire branch, of course, and from the root itself, from the physics on our daily life experiences. So thank you again. My name is Luke Sileza. And again, stay safe and God bless.